This session will see the what is the model in a predicate logic. See, like when you in case of your proportional logic, we define a model. Model is nothing but like we'll be having this proportional logic statement and some interpretation for the proportional logic statements are done. Like for each variable, we'll be assigning either true or false statement, and we are going to verify whether the model tends to true or not. But when it comes to a predicate logic, it is totally different. Like we cannot directly make a substitution of true or false statement to any kind of your proportional variables. And also here we have certain variables. Okay, we cannot directly make a substitution. So here a model in a predicate logic is always defined over a universal set. Okay, so that is very important. So we can say that a model is always defined over a universal set. Like we'll be mentioning for all x and there exists certain x and y, right? So we have to mention what does this for all means. So it is always defined to a certain rules. Like I can say in the set of natural numbers, I'm going to define a function. Okay, so that is called a model. So first step in model is defining a universal set. Our next step is defining all the predicates and the logical connections, the predicates and the logical functions. So I'll give it with an example. So first example I'm just going to give is I'm just going to define my model over a universal set. Like it is regarding your state transition diagram. So first step, I'm going to have a transition diagram. I have three states A, B, and C. So my universal set is ABC. Okay, so universal set I can represent as A. A is A comma B comma C. This is my universal set. And the relationship is the transition diagram. And the transition diagram always have a starting state and set of final states, right? So I define an I over my model is A. Initial state is A. And I can have set of final states. So set of final states of my model is given as B and C. So B and C are my final states. And I'm going to define the relationship. Okay, so this is totally disconnected, right? I have A as a starting state, B and C as a final state. Is your state transition diagram complete? No, right? I should have a transition from one state to other state. Your starting state and these two are final states. So I should have a transitions, right? So that is mentioned in this relationship. So relationship, I can give it as A comma A. This is your transition. This is an example. You may have any number of states, any number of relationships, something like this. Okay, this is one sample example. So this is the defined relationship. Okay, so here A to A, I have a transition. A to B, A to C, I have a transition. And B to C, we have a transition. C to C, we have a transition. So these are all the possible transitions in the given state transition model. Okay, so in this model, we'll be defining certain predicates. And based on the predicates, we are going to verify. So these are all your predicates. So when I give R of A comma A, it means the predicate with binary variables. Okay, and I'm going to say that whether it is valid or not based on my model. Okay, I'll take certain functions, some predicate formulas like there exists a Y where I can have relationship of Y comma Y. We're going to verify whether it is valid or not. So validity of a model is always included in the universal set that is defined. It is not overall. Okay, it is based on certain set that we have decided. Okay, so what does that mean? For all Y, for there exists a Y. So at least one Y is there and Y may take any value from A or B or C. And I should have a relationship from I to A. So I value is A and Y value is A or B or C. So I should check whether any relationship like this exists. A comma B, B, A comma C. So A comma A is there, A comma B is there, A comma C is there. So this is valid. And similarly, when I write it as for all X, R of I comma X, this is also valid. X is a variable and X can take either A or B or C. So all this are satisfied. Hence, this is also valid. Okay, so this is why, like how we write a transition diagrams. Okay, so this is one example and I'll show you one more example to understand this model better. set of all natural numbers. My universal set, like the model that I have defined is like n, set of all natural numbers, some function p dash and f dash. Okay, so here n is all set of natural numbers. So this is my universal set, and p dash I can define it as less than function. Okay, and f is given as f of any n is given as n plus 5. Okay, so now the model can be defined as for all, like for all the natural numbers. I'm going to define for all the natural numbers, like I can write it as all n p of x comma f of x. What does that mean? For all x, and p's function is less than, for all x is less than f of x function. Okay, so it is all set of natural numbers, right? Now the validity of the function actually says that if I take 5 and f of x will be 5 plus 5 will be 10. Always it is added plus 5 function. Plus 5, the value is going to be greater. Okay, so this is how we define a model. So a model is defined for any predicate logic statement, for first order logic statement, over certain universal set. First step is defining the universal set. Next step is defining all the predicates, and next step is defining all the functions. So for this predicate and for this function, you're going to verify certain predicate logic formula is valid or not. Okay, so this is how we do it. Thank you.